This video will show you how you can use transfer learning in RevEyes ML to retrain an image classification model on Windows without having to install Python or write any code. And by the way, RevEyes ML is available for free download at idealeyes.com. For this example, we'll start with the EfficientNet model, which is pre-trained to identify the 1,000 classes of objects in the ImageNet dataset. We'll retrain it to focus on identifying 3 classes of objects: apples, bananas, and oranges. You could use the same process to train it for whatever kinds of objects you need to identify. Before you use RevEyes ML, you'll need to prepare a set of images to train your model with. As you can see, I have my images organized into a training folder and a validation folder, each of which contains a numbered subfolder for each of the kinds of fruit, and each of those subfolders contains a collection of images of that particular fruit. If your images aren't organized this way, I'll show you a little later how RevEyes ML may be able to quickly reorganize them for you. For now, let's go back to RevEyes ML and load the EfficientNet ML model. We'll get it from TensorFlow Hub, which will save us the trouble of manually downloading it. One thing I want to point out is that if you're going to retrain an EfficientNet model in RevEyes ML, you'll want to choose one of the V2 versions. If you use one of the original versions, you'll run into trouble if you try to save your updated model in Keras format because of a bug in the version of TensorFlow that we use on Windows. I'm going to use all the default settings for loading the model, so we'll just click Load, and in a few seconds we'll have the model loaded. The next step will be to edit the model. We'll scroll down to the very bottom of the list of layers and remove this last one named Predictions. As you can see here in the Output Shape column, this layer outputs 1,000 different numbers, which is one number for each of the 1,000 object classes in the ImageNet dataset. We want to focus on just 3 object classes, apples, bananas, and oranges, so we need to replace this layer with a new dense layer with the number of classes set to 3. I'll name the new layer Classify, just because. It doesn't really matter. I'll change the number of classes to 3, and I'll change the activation function for this layer to Softmax. What Softmax does is to ensure that the 3 numbers that this layer outputs are all in the range 0 to 1 and that the total of the numbers is 1. If you're familiar with the math involved in probabilities, you probably noticed that a set of numbers between 0 and 1 that total to 1 look like probabilities. In this case, the first number will be essentially the probability that the image is an apple. The second will be the probability that it's a banana, and the third the probability that it's an orange. Whichever of those numbers is the highest tells us what we have in our image. So with all of that set, we'll click Commit Changes, and with that we've updated the structure of our ML model. Next, we need to train that last layer that we just added using our training images, and then verify the accuracy of that training using our validation images. Here in our dataset options, we'll select the folders where we have our images. I already had the paths to those folders set, but I'll reselect them just to show you how that's done. And then I want to point out 2 other settings in this dialog that are pretty important. The first is the rescale setting. Usually when we talk about scaling images, we're talking about the image dimensions, but in this case, rescaling refers to changing the ranges of the pixel values. In most images, the numerical values of the pixels ranges from 0 to 255, but some ML models need those values to be rescaled to floating point numbers in the range 0 to 1. If this model needed that, I'd change this second number to 255.0 so that each pixel value would be multiplied by 1, which wouldn't change anything, and then divided by 255. Since I'm leaving both of these values at 1.0, since they're the same as each other, no rescaling will be done, which is what we need for this ML model. The second setting I want to look at is the image size setting. Some ML models require images to be cropped or scaled to a specific size before they're processed. And even if they don't require it, many ML models work best if the images are scaled to a particular size. The model we're retraining works best with images scaled to 224 by 224 pixels. Now earlier I mentioned that if your images aren't organized into training and validation sets, each with their own numbered subfolders for each of the object classes, RevEyes ML can help you reorganize them. That's done in this dialog, which can help if you have a CSV file listing each of your images and its object class, and/or if you need to split your images between training and validation sets. We don't need to do that today, but I just wanted to show you where to find that feature if you need it. So now let's look at our optimizer options. The optimizer is the part of the program that gradually adjusts the numbers in your ML model to try to make it more accurate. Some optimizers work better with particular kinds of ML models. In our case, we'll use the Atom optimizer, which is a good general-purpose optimizer, and we'll use its default settings. The last settings that we'll look at are the fitting settings. Fitting is the process of tweaking the numbers, or the parameters, in an ML model to find the values that fit the best for what we want the model to do. The number of epochs is the number of times we're going to repeat the process in order to try to find the best values. In this case, I don't expect to actually need 100 epochs, so setting this number this high would probably be a waste of time and electricity, except that we have this other setting, early stopping. Early stopping enables us to automatically interrupt the process without having to complete all 100 epochs if we notice that the most recent epochs haven't been doing much to make the model more accurate. Using the settings you see here, we'll do that by watching for when the validation loss, which is basically how far off from perfect our validation scores are, when it changes by less than 0.001 over the course of 10 epochs. With that, we're ready to go, so let's retrain our model. When we click the Train button, RevEyes shows us how many images and object classes it found in both the training and validation sets, and then it starts the training. The first epoch always takes a little extra time, but once it's done, you'll see that we're completing an epoch every few seconds. By the way, I'm running this demonstration on an RTX 3060 Ti, not the latest greatest GPU, but it's certainly capable. If you don't have an NVIDIA GPU, you can still run RevEyes, but it'll just take more time. And if you do have a better GPU, it'll be even faster. If you've been watching the numbers, you'll have noticed that our training and validation loss numbers dropped pretty quickly at first, and while they're still going down, our progress is slowing somewhat. And as the loss numbers have dropped, the accuracy numbers have risen, except of course for the validation accuracy, which actually managed to reach 1.0 or 100% accurate in the very first epoch. That really shows just how powerful transfer learning with ML models is. Since we only have to retrain the final layer of this model, we immediately benefit from all the training that went into all the other layers, so we're able to achieve extremely high accuracy very quickly. Now, I'm guessing you have better things to do than watch all the remaining epochs at 1x speed, so let's fast forward to epoch 43, where we'll see that the early stopping setting has kicked in and interrupted the process for us. As you can see, the model is now getting 100% accuracy almost all of the time, and this only took us a few minutes. So next, let's look at our new model in action. We'll click the Use button here to manually use the model to identify some fruit. We don't need to edit any of the settings, so I'll click this button, select an image, and I'll take one from our training set since I don't have any other images handy. Should have thought of that earlier. Since we're using an image of a banana, which is class number 1 in our data set, that's what we'll expect the model to identify it as. And sure enough, the argmax value that gets displayed here is a 1, which means that of the 3 numbers the model gave us for that image, the number for class 1 was the highest. The first number is for class 0, the second is for class 1, and the third is for class 2. So let's try a few more images. An orange, which is class 2, and sure enough, we get a 2. And finally, an apple, which is class 0, and sure enough, we got a 0. Now, just to be sure this is clear, the raw numbers are being displayed in scientific or exponential notation, where, for example, e minus 0.4 means that to get the actual number, we need to move the decimal point 4 spaces to the left. So this number is actually 0.00036. For this one, we only need to move the decimal point 1 space left, so this number is 0.999, etc., which, if we're treating the numbers as probabilities, means that we're more than 99% confident that the image was a banana. And the third number has lots of leading zeros like the first one, so we're confident it's not an orange. So our model's looking great, so now let's save it in a format that we can use outside of RevEyes in our computer vision applications. RevEyes can save in several formats. The 2 most common are probably Keras format, which is useful if you're planning on reloading the model for additional editing or retraining, and TF, or TensorFlow saved model format, which is commonly used when deploying a model that doesn't need to be trained any further. I'll save our model in Keras format, and we'll name it EfficientNet-Fruit. And there it is. This is our new ML model. So finally, let me show you our new model in action in a different environment. Behind the scenes, I saved a copy of it in TensorFlow saved model format, and I've loaded it in the ML tool in Optimize Developer. This is a Windows program that you can use to create computer vision solutions without having to write any code, although I will point out that it has a C++ API that you can use to create new tools if you need it to do something that it doesn't support out of the box. You can also ask us to create a new tool, and we will seriously consider it. We add new tools reasonably regularly. I won't go into too much detail about how the ML tool works in this video. I have other videos you can watch if you're interested in that. Suffice it to say that I've loaded a few of the images that you saw earlier, and we're going to use our ML tool to identify what's in them. So with this banana image activated, I'll click the Image 1 button to ensure that this is the image that the ML tool is processing, and I'll click Process. With the tool set up the way it is right now, you'll see that it outputs 3 numbers similar to what we saw in RevEyes ML, except that I've used this setting up here to multiply each of them by 100 so that they look more like percentages. So in this case, it's pretty easy to see that the image has been identified as object class number 1, which is a banana. And we can do the same thing with the other banana, and you'll see that it was correctly identified. And finally, we'll do the same with an orange. And now object class 2, the orange, has the highest score. But what if, instead of just showing us the scores, we wanted the tool to tell us which score was the highest? To do that, we'd change maximum rows to 1, since we only want one row of results, the highest score, and we'd set the method used to select which row to display to maximum values. And now, if I click Process, you'll see that the results tell us that row 2, meaning object class 2, or oranges, had the highest probability score. So you might wonder, how is this any more useful than what we saw in RevEyes ML? And the answer is that these numbers we're seeing here are not just getting displayed for us to look at, they're also getting saved in variables that we can use in scripts to automate entire processes, without having to write any code, by the way. You can see in some of my other videos how we create scripts in Optimize Developer. So for this example, the variable fruit class 1 contains the score number that we saw earlier, and fruit class 1 row contains the number 2, which identifies the image as an orange. If I select an image of a banana and run the process again, the value of fruit class 1 row changes to 1. In an Optimized Developer script, we might use these numbers to determine which script steps to execute next, like doing something to raise an alert if we found a banana in our orange bin, or we could use our lookup tool to look up the number 1 in a list of object classes and display the word banana on the screen. The important point is, as you can see, with just a few minutes of retraining, we can now use our ML model in a computer vision application to identify whatever classes of objects we need it to identify. I hope you've enjoyed this video and that RevEyes ML can help you prepare computer vision models for whatever applications you need. If you know someone who could benefit from an easy tool for retraining ML models on Windows, please share this video with them and let them know that RevEyes ML is a free download at idealeyes.com. Thank you.